Okay, ji, we are back. Can you hear me?
Yes, sir.
Yes,
Okay.
sir.
Okay, ji. So now, before the session ended, we started with the zener diode regulator circuit, and in that we have considered that the input voltage and the resistance are fixed. Now we consider that the input voltage is fixed, but the resistance RL of the load is variable. So the starting point is that we would like to see that what should be the minimum value of RL so that VZ should be in the on position, right? Because if VZ is not in the on position, then this means this is not in a regulation mode, right? Or the zener diode is not in the on region. So before that, we would like to see that what should be the minimum value of RL that the zener diode should be in its on region. So let's see. Right. So what should be we can do now? Again, we would like to have the equation VL should be equal to VZ, and that should be equal to, anybody? It should be equal to RL into VI divided by R plus RL, right? Is this thing fine? Or can you hear me?
Yes.
Yes, sir.
Yes, sir.
Is the equation fine? Okay, Ji, if I want to see what is going to be the minimum value of RL, so what I can do, I multiply VZ with R into RL, and this thing should be equal to RL into VI, right? And similarly, if I want to take RL on one side, so RL will be equal to RL, or I can write VI minus VZ is equal to R into VZ. Are you with me? Can you hear?
Yes, sir.
Yes, sir. सर इसमें हमने वो किया है वोल्टेज डिवाइडर रूल अप्लाई किया
जी जी वही वोल्टेज डिवाइडर रूल अप्लाई किया
सर उसमें सिर्फ आर नहीं आएगा ऊपर आर आर वी आई नहीं आएगा
आर भी आएगा आर यू श्योर
जैसे जब हम पहले किया था जब हमारा वी एल इज इक्वल टू वी आई इंटू आर डिवाइडेड बाय आर प्लस आर एल आ रहा था क्योंकि हम उसमें दो वो रजिस्टर लेते हैं जो कि हमारे जो
आर यू श्योर हमने आर एल इंटू वी आई लिखा था पहले भी because what you need that portion of the current which is flowing through the potential which we are calculating, right?
Okay, sir.
ठीक है जी. And now we are playing with the values, and to find the minimum value of RL, so what we can write, RL minimum should be equal to R into Vz divided by Vi minus Vz, right? So this means this value is going to give us the idea that whether it is going to provide, that this minimum value is going to provide that the zener diode is in the on region, right? If the value is less than this minimum value, so this means the zener diode will not be in the on region, right? So to be in the on region, the value of RL minimum should be this one, so that the regulation or the role of zener diode should be there. ठीक है जी. Can you hear me now? आवाज आ रही
Yes,
है?
sir.
Okay.
Yes, sir.
Okay, so this means RL minimum should be there, so that the zener diode should be in the regulation mode, right? Or it should be in the on region. Or we can say that once it is in the on region, then we should have the IL maximum, because once we have the minimum value of RL, this means we will have the maximum value of the current that will be flowing through the load resistance, and that will be equal to VL divided by RL. Are you with me? Or this we can write,
Yes, sir.
this means we can write, which is equal to Vz divided by RL minimum, right? And once the zener diode is in the on region, once the zener diode is in the on region, we can say that VR is equal to Vi minus Vz. Are you with me? ठीक है जी?
Yes, sir.
Right? So once it is this, so what does this means? This means that if the value of if we change can you see the circuit? Okay. Now at the circuit, if you see, if we change the value of RL, if we change the value of RL, this means from the minimum value, if we increase the value of RL, what will happen? If we increase the value of RL, what will happen? This means the current flowing through the RL will decrease, right? And once the current flowing through RL will decrease, but the voltage across RL will remain constant due to the zener diode, right? And we also know this thing that the current IR will remain constant. Why? Because if IL will decrease, right? If IL will decrease, the increase in the current to keep the IR constant will be taken by the increase in the zener current. Are you with me?
Repeat, sir, please.
Okay. What we say that if I say if I increase the value of RL, right? If I increase the value of RL, the current flowing through the load resistor RL will decrease, right? So if the current flowing through the load resistor RL will decrease, but the total current IR needs to be kept constant. And how it will be kept constant? Because when IL will decrease, the increase will be taken by IZ, right? And this means the output voltage Vz or VL will be constant, and the increase or decrease in the current will be taken by the zener diode. Are you with me?
Yes, sir.
Right?
Yes, sir.
So in this way, if we change the value of the load resistor, the output will be kept constant equal to Vz, and the increase or decrease in the load current is being countered by the decrease and increase in the zener current, and the voltage will be kept constant, right? Are you with me?
Yes, sir. Yes, sir.
So
Yes, sir.
this is the case when the input voltage is kept constant and the load resistance is variable. Now if we change the role, this means that if I make the load resistance constant and I make the input voltage variable, right? If I do this thing, right? Now what will happen? Now this means when we are increasing or decreasing the value of Vi, this means the current IR will change respectively. Are you with me? Can you hear?
Yes, sir.
Okay. So if I increase or decrease the value of Vi, the corresponding increase and decrease in IR will take place, right?
Yes, sir.
Now, if I increase the voltage Vi, what will happen? That there will be that if I increase the value of Vi, what will happen? That the current IR will also increase, right? When the current IR will increase, so where the increase of this current will take place? Anybody?
IZ.
So this
At the
means
diode.
IZ will increase, and once IZ will increase, this means VL and VZ will remain constant, right? And similarly, if I decrease the value of Vi, so this means there will be a decrease in IR, and the decrease in IR will be countered by the decrease in IZ, right? So in this way, the zener diode is regulating the output voltage even though the input is varying, or even though the output load resistance is varying, right? So in this way, it is able to counter the effect of the variation in input or in the output. Okay, so what we have few examples with this. So the first example is example 2.26, and then we have example 2.27, and then we have example 2.28, right? So these examples are basically the assignment for this week, right? So before that we have example 2.23, then example 2.26, and then example 2.27, and then example 2.28. ठीक है जी? So these are basically the assignments, right? Are you with me?
Yes, sir.
Yes, sir.
फोर्थ पॉसिबिलिटी
Yes, sir.
रह गई सर.
जी?
फोर्थ नंबर पॉसिबिलिटी सर, फोर्थ पॉसिबिलिटी रह गई सर के जिसमें आरएल भी वेरिएबल हो और वीआई भी वेरिएबल हो.
ओके, आप कर सकते हैं. इट इज द सेम थिंग दैट अगर आप RL को भी वेरी कर रहे हैं और आप जो है VI को भी वेरी करें, एज लॉन्ग एज the zener diode is in the on region, so again it will be able to make the output regulated, right? So it's there because
सर हमें ये किस तरह पता चलेगा कि जीनो डायोड ऑन रीजन में है या ऑफ रीजन में है?
देखें
ये वीजेड का किस तरह पता चलेगा?
the starting point which I have told you, that we would like to see that whether if we take out the zener diode out from the circuit where we started with that whether VL is keeping the zener diode in the on region or off region, right? So we started with that point. If you remember, or if we go back, and in the circuit we said that if there is if there is a circuit like this, right? And in this circuit, we said that if we take out the zener diode from the circuit, right? If we take out the zener diode from the circuit, so we are left with the resistance R, and we are having the resistance RL, right? And then we checked what is the value of VL, right? So if the value of VL is less than VZ, this means the zener diode is in the off region. If the value of VL is greater than VZ, this means the zener diode is in the on region, right? So from this point we started with, right? So in this way, we will know that whether the zener diode is in the on region or if it is in the off region. Are you with me? Can you hear me? Can you hear me?
Yes, sir.
Sir, we could not hear you. Kindly repeat, sir.
Okay, ji. Just have a look again. What I am saying that we started with this circuit. Can you see the circuit?
Yes, sir.
Okay.
Yes,
So
sir.
in the circuit we started with that if we take out the zener diode out from the circuit, we are left with only the resistor R and the resistor RL and the input voltage VI. And then we calculated the value VL, and we checked that whether VL is smaller than VZ. If VL is smaller than the value of the zener voltage, then this means the zener diode is in the off region, right? And
This sounds good.
if the VL value is less than VZ, we say that the zener diode is in the off region. If VL is greater than VZ, once there is no zener diode in the circuit, so this will show that the zener diode will be in the on region. Now if the zener diode is in the on region, this means once the zener diode kicks in into the circuit, this will not allow the voltage of VL to go above VZ, because once the zener diode is in the on state, it will try to regulate the voltage at the output, right? And whatever the increase in the current or decrease in the current is going to be there in the circuit, it will be passed through the zener diode, and it will try to maintain the output value equal to the zener voltage, right? So there may be different cases. There may be like if the input is keeping constant and the output load resistance is varying. So in that specific case, we have seen that if the output load resistance is varying, so this means if we vary the output load resistance, or if we increase the output load resistance, the load current is going to decrease. When the load current is going to decrease, this means there will be an increase in the zener current, and the current through the resistance R will be kept constant. Why? Because we have this equation over here. The equation shows us that we have IR is equal to IZ plus IL. Applying Kirchhoff current law at the specific node, we get that if there is an decrease in IL due to increase in RL, that will be responded by the increase in IZ, so that the total current IR is being kept constant, as well as the voltage across the load is being kept constant equal to VZ. Similarly, if we try to vary the input voltage VI and the output RL is being kept constant, So again, in that specific case, what will happen, that we will have actually an increase in IR. We will have an increase in IR, and that increase will be actually have an increase in IZ, right? Again, increase in IZ, but keeping VZ constant, right? Similarly, if we decrease the input voltage, there will be a decrease in in the input current, or there will be decrease in IR, and that decrease will IR being countered by decrease in IZ and keeping VZ constant, right? And then there was a question that if VI and RL both are being varied, so if both are being varied, so again, as long as the zener diode is being kept in the on region, it will be regulating the output voltage equal to VZ. But if due to those variations, the zener diode is not being kept in the on region, then there will be no regulation in the circuit. ठीक है जी. So with this, what we have the assignment for the zener diode with the example number 2.26, example number 2.27, and then we have the example number 2.28. ठीक है जी. So can you hear me?
Yes, sir.
Yes.
Right?
Yes, sir.
सो अगर आपको कोई कुछ लोग अभी भी जो हैं व्हाट आई हैव सीन दे आर स्टिल नॉट इन द गूगल क्लासरूम, सो दे कैन एक्चुअली डायरेक्टली ईमेल देयर असाइनमेंट टू रोल अमीन साहब. ठीक है जी.
Okay, sir.
And the other thing is try to get access to Google Classroom, because everything will be uploaded into the Google Classroom. ठीक है जी.
Okay, sir.
Even if you missed some portion of the lecture, so at the end of the lecture the things will be converted into the video formats, and then after processing the all the session is going to be uploaded on the Google Classroom. ठीक है जी. So even you miss some portion of the lecture, you can still catch up with the Google Classroom. ठीक है जी. So
Okay, sir.
and the other thing is next week we will be having the quiz, so try to prepare yourself for the quiz, and therefore just go through the course which we have covered up till now. ठीक है जी. So probably there will be one or two quizzes depending upon how much time we will have after that. But I will suggest if you have more quizzes, this means there will be more opportunity to have good grades for before midterm. ठीक है जी. So
Okay.
that's it for today. Okay. Thank you.
Okay. Thank you, sir.
Thank you.